Okay, today we're going to be looking at section 2.3, quadratic functions in one variable. Number one, we want to solve the quadratic equation by factoring. I do plan on putting a list of steps that will help you factor in your Blackboard course. As of right now, it's not, but if you follow the process, you'll be able to go through and work all of the factoring problems. So I'm going to also refer you to your Blackboard course. We'll start here, and then the Getting Started videos. There is a free calculator download. I will be using this calculator to show you how to get all the factors. And let me open that up here. Let me downsize it just a little bit, as much as I can actually. We're going to be using that to help us with the factoring problem. Okay, so with number one, this problem is out of order, so I'm going to rewrite it and put it in standard form, is what we call it. So this is 8x plus 3x squared equals 35. Okay, standard form will have our x squared term out front, and then our x term next, and then our constant on the same side, and then 0 here. So I can just rearrange these guys. I'm going to do 3x squared plus 8x, and then I'm going to subtract 35 and move it over. So it's going to be minus 35, and it's going to be equal to 0. So this is standard form. Whenever you want to do factoring, you need to make sure your leading term is positive, and then once that's the case, we can factor. If it's not positive, then you would divide everything by a negative, or you can multiply by negative and just change all the signs and then factor it from there. Okay, so the process that I use, you're going to multiply the first number, so the leading coefficient right here, the 3 and 35. You're going to multiply those two together first. 3 times 35 will give us 105. Now, don't worry about the sign. I know it'd be a negative 105, but that's not important right now. We're going to use that sign here in just a minute. Once you get that number, we're going to write down all the numbers that multiply to give us 105. Now, you don't actually have to write them all down, but it helps. Like 1 times 105 is not divisible by 2, but 3 and 35, and then you can continue going. Now, sometimes you'll get big numbers that's hard to reduce, and so there's other methods, which I'm going to show you. That's why I want to pull up the calculator. I think the next one we would get would be 5 and then times 21, 5 times 21, and then there'll be more. But let me show you how to get that full list. So you get your calculator, turn it on. You're going to go to y equal at the top. That's the top left button. I'm going to clear out what's here. And then in the first y response, I'm going to insert the number that we're trying to divide, which is 105. And you can type the buttons, or you can click them. And I'm going to do divided by. So I'm taking 105 and I'm trying to divide it by all possible combinations that will work. The way you tell the calculator to do that is you want to do divide by x. So that's the button right next to this green alpha key. So you click that, so you got 105 divided by x, and then I want to see the list. So to see the list, you're going to do second and then table. It's going to show you the table of points. And the first few that I have are there. So 1 and 105. 2 is not a whole number, so we skip it. 3 and 35, that's what we originally multiplied to get 105. 4, not a whole number. 5 and 21. And then as you go down the list, the numbers are getting closer together. We have 7 and 15, so I'll add that one. 7 times 15. And then that might be close to the end. I think we get 9. Nope, that's not even. That might be it. 7 and 15. It's going to be the end of our list, because then 15 and 7 just repeat. Okay, so we have our list here. And what we're looking for, so now this sign is important. I'm going to use this sign. This tells me what to do. I'm going to put 2, 2. So I want to subtract these numbers since I already used the first and last. Now I got to figure out the middle. I want to subtract these numbers and see which one gives me an 8, if any of them. So 105 and 1 is going to give me 104. It's going to give me 32. This is going to give me 16. This will give me 8. So if you find the pair of numbers that when you subtract give you that middle number, then the problem will factor. Okay, so now what you do is do 2 sets of parentheses. We're getting close to the end here. And this method is a little bit different. Some instructors don't like it, but I like it because it works every time. It's just not 100% mathematical correct in what we do, but this process again works. So here's why we don't like it. There's a 3 here. Whenever you have a number out front, then there's you used to have to play this guessing check, try to figure out, okay, which term goes where. Does the 3 go here? Because 3 times 1, we got to use those factors. Does the 3 go here? Does it go here? And then you got to figure out a whole lot of things that are going on. So in order to get rid of the guessing game, I'm going to put a 3 in both. Okay, and we're going to correct it in just a minute. But I also let myself know that this is wrong. Normally in math, as you're going through, you should be able to check at any step and get back what you started with. But right here, if I was to FOIL this and do 3 times 3, I would get 9, and that's not correct. So I let myself know this is wrong, but we're going to fix it. But I put a 3 in both of them, and anytime I have a leading coefficient, I'm going to put that number out front of both, and we're going to fix it at the end. Then we take our x squared, that's with our leading coefficient, and we're going to split that up. We're going to give an x here and an x here. And then we add to the back the 2 numbers we found, the 7 and the 15, and it doesn't matter where you put them. You can put them in either one. It's going to be the same. Okay, once we do that, then we come back to the first sign. It is positive. That is indicating the sign of the larger number. So from here, you need to figure out minus, positive, or what sign goes here. And you can kind of use some math intuition, like if you use 7 and 15, what do I got to do to make this equal positive 8? So the 15 has to be positive. That's a bigger number. You have to subtract the 17. But here's the way the process works. The first sign in your problem tells you the sign of the larger number. So out of 7 and 15, 15 is larger. So it's going to get a positive. And then I'm going to say big pound sign for number. So the big number gets the first sign, whichever one's bigger. If they're the same, either one of them, it doesn't matter. Because sometimes you might get the same number. Like it could have been 7 and 7. And then you go over to the last sign one more time. And positive means the same. And then negative means different. Okay, so if this second sign is positive, that means both of these are going to have the same sign. If the second sign is negative, then they're both going to have different signs. Okay, this is not saying that the other one is negative. It's just telling you same or different. Because if this was negative, that means my bigger number would have been negative. And then if that was negative, they were different, so this would be positive. But you'll see as we do more. But anyway, this one is negative, so they're going to be different signs. So if that's positive, this is different, it's going to be negative. But again, you can kind of use some math intuition. So at this point, we're done with the factoring process. There's one more thing we have to do. We have to fix what was wrong. So the way you fix it is we're going to reduce. We're going to look at 3 and 7. Can I divide 3 and 7 by something so that they get smaller? And the answer is no. So we're going to leave this set of parentheses the same. We're going to leave it as 3x minus 7. All right. The next that we're looking at 3 and 15. Can I divide 3 and 15 by something? Well, yes. We can divide both of them by 3. So that 3 we're going to divide by 3, and we're going to get rid of it. That's going to correct the putting 3 in both. So if you divide by 3, it's going to leave you with just 1x. And 15 divided by 3 is going to leave you with 5. And so here, this problem is factored, and it is correct. So if you were to FOIL and distribute this out, you would get this original problem back. Okay, so the last thing we have to do is solve for x. So we're going to set both of these equal to 0 and solve. So we have 3x minus 7 equals 0, and x plus 5 equals 0. So we're going to add 7 to both sides of this equal sign. It's going to bring that to 0, bring down to 3x equals 7. And then we're going to divide by 3. 3 divided by 3 is 1, and then we have x equals 7 over 3. And I'm going to leave it in fraction form, so I don't have to deal with decimals. And then here we just have to subtract 5 from both sides. And my pen just seems to be fading on me. X equals negative 5. So these will be our two solutions, 7 over 3 and negative 5. Let me do the division bar first. 7 over 3 and then negative 5.